Ray Kaderli here with the first episode from the field of the Hemp Build Podcast, and we're here at CannaVision with CEO and President David Russell. Now, when I talk about the cooks in the kitchen that are coming up with the building science materials that enable architects and building professionals and building scientists to come up with these materials made from hemp, the cooks in the kitchen that I'm talking about are here. So the hemp industry is maturing as a supply chain, and the capabilities are here. We'll talk about that more in a minute. But first of all, David, introduce yourself and tell us how you got into this and a little bit of the journey, and then we'll go inside and see what's going on.
Yeah, thank you, Ray. Very excited about being here. Very excited about showing everyone what we do and why we do it. And I guess I should just jump in and say why we do it. We do it for our farmers, really. This plant gives our farmers an opportunity to actually have an income, not break even that they're used to, and more importantly, that led us to our why. Farmers can grow, but then what do they do with it? Well, we've discovered that this market is growing and that you need a little bit more than just farming, processing, and a market. You actually got to start in the beginning. You might have the end in mind, but the reason we do what we do is because the need is there, and it just, and I apologize for the pause, but I do get emotional on the farmers. I can't stand it when they say, let's just break even is good.
Yeah.
We can grow, our farmers can grow, but the building behind us has some technology, it's got some innovation. We've got some fun things back here to show you why Ray says the cooks are in the kitchen. And I think more importantly from a processing side is we're not only a processor, but we're a processor for other processors.
Right, and so you can take the technology that you have and then take the raw material that might have one or two steps done and do some finishing steps to it as well, and then that enables building scientists to come up with the materials that are needed to really advance this technology. And now when I introduce processors, I often make the comparison of a hemp processor is a lot like a sawmill. So a sawmill in the forestry industry can make LVLs, glulam beams, trusses, dimensional lumber, chip lumber, and pressed products. A lot of different things can take place on the forestry industry, and we're going to see a lot of that take place in the hemp industry, and then that's what the equipment will do. And so as a professional in the building place, for you, what we want you to know is that this is available to you. The farmers are growing, the yields per acre are higher. This is a U.S. American fabric across all sectors story that is so positive, with a lot of good growth and economic engine that comes along with it. So anything else before we go inside?
We're just excited to share what we have and why we do it with you.
Let's get to it. All right, in the forestry industry, everything starts with taking down a tree. In the hemp building industry, everything starts with what looks like a bale of hay. This is the hemp coming in from the pasture. So Davis, tell us the beginning of this process and what's taking place right here when it comes off, and this is the beginning process of us ending up with building materials.
Yeah, hey guys, first step, we get the bale from the field, and we've got it in this machine here, which is a unwinding machine. So in the field, the farmers are using a baler and they're winding this up for transport. Here,
traditional hay equipment.
Traditional hay equipment. Here, we're unwinding it. So that first step, bale goes in, and this machine is going to unwind the bale.
So a lot of times you see also big square bales coming in, and so there are the different equipment that have either square bales, round bales, but it all comes in like this out of the field. It's easy, and this is where we like to also point out that this grows from seed to harvest in what, 120 days somewhere?
With this variety, we're looking at about 90 days.
Wow. And then a tree, do the math on how long it takes to grow a tree to full harvest. This is something you can do year after year, season after season. All right, so from what I've understood is you break the hemp, and that breaks the woody part, and then that leaves the fiber. The fiber goes off for textiles, but when I'm building a house, I want the woody part, and that's what makes the insulation. And then so what we need to do is decord it. Talk about this process, and then we've seen it unwind. Once it unwinds, what happens?
Yeah, so really here's the magic sauce, is when you're unwinding the material, there's some efforts that need to be in place so you're not damaging the material. So we've got the bale, it's all intact. The unwinder is unwinding it. We're unwinding it. It's got the fiber and the hurd in it. Through proprietary technology, we have to now separate those two materials. And how we do that is through a snake-like motion. And what that does is protect your fiber, and it starts breaking apart the hurd.
And so what you need to know as a building professional, if it's your architecture, is that there are a couple of different ways to do this, and then you need to make sure that you know where this is coming from, and then we'll show you how this meets specification once it comes out of the process. But everything is on a larger scale, and this is on the entry side of it, and we'll show you what comes out the other end so that you know about your material and how to spec it.
And Ray's correct. This is an important step for speccing at the end result.
So what do we have coming off here? We've broken the hurd part, and then now we've got fiber that's separating. What's this step?
So we've got separation happening, and when you have separation happening, we're using a shaker table that will actually take the broken pieces of hurd, fall through the grates, and then allow the fiber to come through.
Separation, and now the building materials go off to one side, the textile materials go off for further processing. All right, so the initial processing has taken place. There's some sizing that's going on as far as separating out the small from the large from the medium, and then this is where it comes down and into some packaging that we're starting to see familiar on a job site where the supply chain will deliver to you. Tell us what's going on here.
Yep, so right here we've got some further dedusting as well as the separating of material by size. So we've got filters in here that we can adjust depending on the order, whatever the engineer's looking for. And this machine here goes through the process. We've processed it through a few machines now, and now we're collecting the end result. So we've got 3 different options of material that we're getting out of a plant.
Let's keep moving. All right, so this is where it's just like a magic process. So you're using sonic technology to break apart the things, separate the things, make it into powder. It's like a magic processing unit. Tell us about the machine, because this is something that is unique to y'all's processing facility. Yep. You've licensed this technology for the whole country to be able to do this, and now you can deliver a lot of different products, and we're going to take a look at those in a minute. But what does this do?
Yeah, as I mentioned earlier, we're a processor that helps other processors. So what's behind me is technology that uses frequency to liberate items along their natural lines of fissure. So what that means is we're able to, with a computer control, dial in some variables and take a 2 to 4 inch piece of material and within seconds, less than seconds, make it micronable. Is micronable a word?
It is now. And so
there we go.
You can not only separate the fiber from the hurd, the textile part from the woody part, you can also micronize those together. It might be used in composites or other building materials. If I'm going for Hempcrete, you can separate out the fiber that we want out of the mix and size it all down just by dialing the frequency or the gas pedal effect.
Yes. And so to give an exact example, we can take material that processors have limitations on. They can only make it a certain size. Well, let's just say building code requires 1/8 of an inch smaller. Mm-hmm. They're not able to do that. They can reach out to us. The machine behind us will take that material and resize it to the appropriate size. So they don't have lost revenue, not lost product. They can send it to us, we can resize it for them, and they can continue on with their project.
Now what I'm excited about is that you can get a very consistent product for Hempcrete. That's mainly what I'm using in the building right now, but I've also talked to folks about extruded lumber, biocomposite infills on concrete, and other plastics. There are different components that it's like, if they need an ingredient and they need it to be specific, now we can take it to that to where it can, other products can be developed.
Absolutely. We want to help complement the industry. That's going to help grow. It's a missing piece in the market where we're seeing a lot of interest from universities, from private interest, different projects. This machine back here separates us from other processors, and it allows us to complement those processors at the same time.
So when we sit down at the samples table here in a minute and finish up our conversation, what we hope is this stirs your creativity to, hey, what application could you make? Now, we talk a lot about Hempcrete, about some of the other bat insulation, some of the underlayment for carpet, some of the mattresses in the bed, you know, all of the different things. We hope this stirs your creativity to where you make an entry into this industry and you find your niche, because those niches can lead to riches, and they're capable with processors like David on here. So let's keep going down the road. Okay, so this machine is on, and then we're not using any of our external mics or anything like that, but what I want you to notice is, see this spinning and how quiet this machine is, and you can see the spin, and the noise that you're getting is from the dust vacuums over here. And so this is something that the technology has fantastic capabilities with a very low impact, because it's not beating the material up until it's a certain size. It's using the sonic technology to break it up. And then what that does is that lets this machine last a lot longer, run more efficiently. So as sustainability is part of all of our concerns, from the soil stewardship to the processing to the actual fabrication, these sustainable methods are part of the process all along the way, and we want you to know about them.
So now that we've processed the bale, we've hit specs, or did we hit specs, for an order through the micronization machine, because the material wasn't usable before. So let's see what it looks like. Okay, so we've got some separation. And this is something any builder can have on the job site. I think it's 30 bucks for the whole set. It'll give you a great idea quickly that, hey, the material that's bought is hitting spec, in case there's a spot check or quality control on the job site. Something easy for a builder to purchase, have, architect, and have on the site. So we got some fiber material, smaller material. Now we're getting into what you're seeing here is the powder, the micronized further. And then we've got the really fine dust that comes out that we can test. Separated out fiber. So a little bit of the fiber got through. So that's the Hurd that got resized. And everything else is going to be, now we got a lot of micronized dust and fiber. And then it just moves down into more powder.
So you see what volumes by weight and by volume that you achieved, and then you just adjust the machine,
correct,
up or down to get what you want, whether you want it small And this isn't laboratory machinery. This is like crude where you can know what you're sending to the laboratory for more scientific verification. But they're going to use a very similar machine. All right, I feel like we're at the demonstration table of a cooking show. So we went through the factory floor, the machinery, saw how it is all made. So that's how things can be done. Show us what can be done and some of the ideas. Now I know this is the one that I'm after, and then that's for Hempcrete. This is the main ingredient that I use on the building materials. Walk us through some of these other things, such as the difference between, you mentioned animal bedding. There's a customer that wanted it just a little bit smaller and up and down.
Yeah, so in the horse world, we've been working with some different barns and some different scientists, and veterinarians. Within that world, we got to be very conscious of foals eating the fiber. So what they found for the absorbency and all the properties that the plant offers, such as no flies laying their eggs, amazing one, anti-pest, mold resistant, and its absorbent factor. So the reason the animal bedding, we can dial in a spec there, is it doesn't get caught up in their hooves. And with our mixture it's different from Hempcrete because our mixture actually contains about 30% fiber. So it's a nice blend, and that's what makes it different than the building material. Is with your building material, typically you've got a certain spec size of Hurd.
Right, and then now I know that this fiber is fantastic. This is a little bit of a flex because this is something that is nice and clean, and it's wonderful if you're going into any other applications. There's a lot of non-wovens, such as your erosion control mats, other forms of insulation. Textiles is where this goes off to. But when I was mixing up some materials and then there was too much of these long fibers in here, it would stop the machinery in the mixer. And now this is a little pretty small, but a strong diesel engine that can mix a large batch of plaster and hempcrete, and this was stopping the whole machine from turning, and so it's something that you definitely want long fiber out of. Now talk us through some of these other applications, from bats to erosion control, because not just in the building materials for the fire control and the insulation, but the whole geotextiles and everything, we're looking at a lot of different applications.
We are, and I think it's important for an architect to realize is that we can customize length, circumference, length of fiber if that's needed. You can tell we've got the different types of building materials. And then as a processor, we're hitting spec for material. Now we can take it a step further and work with the end user. And like Ray was saying, we got the erosion mats, the insulative material. So when we began in the beginning, you notice we took certain care with the machinery not to damage it. The way that it was unwoven, right? The way we peeled back that onion was with care. And that was with our end users in mind for quality fiber. Now on the building side, it is great to see where this can go because this is all a part of it. But in addition, we can now come down with some plaster mixtures. We can come with the building material itself. And then if we're doing spray insulation, for example, or spraying it in, we may need a little bit of a finer size. So we're gonna go resize this down to either 100 microns, 85 microns. That's the precision our processing goes through.
Now I've played with some of this and mixing it in, and if you'll get in here you can see this is what you can put into a plaster, and then you can take it down so fine to where you don't see any of the particle size in it, but it's just a very fine powder. And I've played with some of that in the plasters that are your finishes. And when you as an architect are called on to be sustainable and healthy, the sustainability, if you can use a natural product like this in conjunction with a lime plaster, now your sustainability scores, you can calculate all that in there. So you can calculate for the erosion control from the site work all the way through to the finished product, even to the finishes, And you know, this is something that you mentioned you're a processor's processor. And this is some things that are made here in the U.S. And look at the beautiful marbling on the finishes. This is a rough product out of Murray, Kentucky called Hempwood. We've also done a podcast with Greg Wilson out of there. But you can see the marbling that you could imagine this with a nice shine and a sheen on it. This is the rough material, but you've got a lot of different finishes that you can come out with. So this is a rough block for a sample, and it's just all the colleagues in the industry are really working together to come up with the best of the best for the architects and the building professionals. So keep going down some of the other materials that you see, and I'll come with some of this right here because I know this is exciting, because you can have this disappear when you're using it instead of an aggregate as an additive.
Yeah, and to complement that, Ray, we're working with a couple different labs and some really smart chemists that are taking the variation of the size, and you'll see that some of this size to us doesn't seem too far off. 53 to 55 microns to 63 to 65 microns. To us, it's really close in size. But to a chemist, they need to dial into some specs. And so what we can do for you is get you as much product A as you need, and you're going to see that you're going to be within a very high percentage. We send all of our material to a lab to get tested, so when you get a batch from us, maybe it's 2 tons of material, it's also going to come with a form that says, hey, we're 98% of spec. Now that's that tolerance that right there's no room for error on that. However, most of our specs are coming in at, as long as we can hit 80%, 82% of the desired size, they're happy with it. So we've gotten great feedback on our precision of our sizing without foreign material in it.
So before we go over and we talk a little bit about spec, we want to know measurement methods. They need to be done at the processing facility. That's what they use to know how close they are before they send it off to a third-party lab for verification. And they're going to use something very technical but similar, and they're going to have an official verification, whereas you as an architect or you as a builder, if you're receiving materials, you can do those simple things as well. And that's why those measurement methods were created, for that simplicity. But the processor does that before they send it for lab verification. You can do it for your own verification. We'll look at that in a minute. Anything else on the table that you want to walk us through as far as the capabilities on the building science?
Well, before we get to that, I want to also mention that it's important on the building materials side. We're a member of ASTM. And that's important as the engineer and the architect to know that really that end product is striving to meet those standards. So it's either going to meet or not meet. And that's our whole goal. When we wear that hat in here, we're sifting, we're shaking. We've got an internal lab that's not official, but it gives us a really good guide as to what material, when we QC it, to make sure we're on path to hit either that min, the max, or really on that target number. But being a part of those organizations help us move this industry forward, and it just builds confidence all the way back from the client. It's going to be in their house, and then work backwards from there through all the pieces. You know, you in your lectures you give 5 different things that you must have, and so I always keep those in mind. But as we go through, you know, we are able to do different sizing, which is nice because with computer and technology, we can press some buttons, control variables, and rest assured we're going to get what we're looking for out of that.
So just like the forestry industry came up with a wealth of products, the hemp industry is going to do the same. They're going to be verified here, and then these are some of the questions that you can engage with your suppliers and your processors and ask them. If there's a need that you have or something that you would like to see for whatever purpose and application, the cooks are in the kitchen, ready to have this cooking show, bring something to you, and then let's go on over and take a look at the rough methods that go into the lab methods, and then that way you will know how to engage in that conversation with your processor all the way to back to your computer to know when you're speccing these materials. Now you get that credit for environmental stewardship, and then the performances like we saw with the fire testing and all of the others.
Yep, and I mentioned processor for processors. We can all dial in our machines to hit the numbers of what we can do here. Again, where we complement is, let's just say there's a big order that comes in, and Oklahoma has a big project going on, and their supplier may be running low because it's a big project for whatever reason. They can contact other processors and say, hey, we need this. When that GC gets that material on site, they know it's going to be the same material they've been working with spec-wise. And so that's very important to us as processors to make sure we're all providing the same ingredients so the people in the field can enjoy it.
And it's consistent.
It's consistent.
So professionals like yourself are engaging with professionals like you guys to where now you know that there's consistency. Because I remember as little as a year ago, there was a phone call I had about somebody looking at a development, and then it would have been several hundred houses. And then we started sharpening a pencil to the numbers of it all, and then it was like, well, that's more than what would be available at that moment in time. Now, fast forward, we would easily hit that number because the acreage is under cultivation, the processors have capacity, and now things are getting exciting. So hope that's exciting for everybody.
They are. So I'm going to add one more item on the excitement list. So we've got great upfront items. One of the neat additives that the pulse wave brings to us is, let's say you want a gargoyle, something complex on your house, right? That's going to be a little bit different, might be a little rough. You may have the building materials, but you got to plaster over it. Well, what if you can go smaller, say 38 microns, 32 microns, and beyond. You can now take this, we'll do this one, for example. That can be mixed on site, poured in a form.
And I'm going to bring this tape measure up here just so you can know exactly what we're dealing with. And it gets smaller and smaller. And so you were telling me that some of this stuff can even go in cosmetics?
It can. When you get down into this area, we've got some cosmetics where, because it's a plant, it's a natural plant, no additives, no chemicals, nothing extra. You can add some pigment to it, and now you've got blush, you've got, oddly enough, some sunscreen capabilities. So
you're limited by your creativity alone. Let's take a look at how this comes from the processing facility to your job site and then verification for testing. So when you get ready to start, and after a while, you've got all your different sizes separated out, but on a more Tupperware level of technology. David, walk us through this, because this is something you could keep in the toolbox on the job site. This is what you're doing like when you're out on the factory floor. Walk us through what you've got here.
Yeah, I think, what do we call this? The Tupperware of sizing?
Yes.
So it's great, it's affordable, it's easy, but it gives you a great indicator. So what you'll do, just like sifting, panning for gold, right? You want to see what you've got out of your capture box. So it starts with the top layer, and in this case, we ran a mixture of hurd and fiber. So what it's done is separated out the fiber. Looks like we've got a couple little hurd pieces that didn't fall through, but that's okay. So then we go to the next layer. And the next layer, you can see the spec we were looking for is in this bucket. Then we go down further, and now we have more of the micronized with still what I call these some of the divers. They kind of went through the screen because they're still small, which is too small for the spec, but they're falling through. So that's what you're seeing here. Now, what this tells me is we could change a few of the variables because we want more of this in this bucket if this was our desired goal. And that's easy to do, and that's why we QC and we keep track of our recipes, right? But now if this was the case, hey, I think we've dialed it in because this one is the most by weight if this was our desired outcome. But then it's still screening, so we can go a little further. And let's say For those applications of plaster or additives or gargoyles or cosmetics, maybe we needed to hit this size here.
And so the screens just get smaller.
So the screens get smaller, and now you'll see that actually some of it is even tinier, and it fits right in here.
Very easy to buy on any online, like on Amazon. You can click and order these sieve tests.
Yep.
And then that's why these sieve analysis tests are so important. So at the plant, you can go through this, and then you'll have third-party verification when you send it off, but you already have a good expectation on what you're going to achieve because you've done this. And then somebody else with a lab
Yep.
says, yes, that is true. And so you've got that third-party verification, trust but verify, ASTM type of specifications. And this is where know that ASTM and other professional organizations that David's a member of that are working on these things are actually engaging in developing these measurement methods, specs, standards, and so forth. Those are coming along the way. So for those of us in the construction industry, we know that there's stat and spec in everything. And so now we'll be able to scale as those things come online and the professionals are coming about that. What do we have here on this one? Does this?
All right, so with this one here, we're looking at the smaller microns of material. So in here, we hit our desired length, and this one here, we're looking at 325 mesh. So will you do the calculation over there, Ray, and look at 325 on that chart for mesh and tell me what our micron is?
44.
44. This is Test Sieve ASTM E11 standard. So you can have the beauty of Tupperware, and then you can take it that next level and get the more calibrated screening, the professional screens. Again, that's just internal, making sure we're hitting spec before we send it off, because ultimately our goal is if we've got a happy client, it works all the way back through to everyone involved, all the way down to the farmer.
It's a lot like doing a slump test. If you're pouring concrete, you're going to get out there, you're going to pull that out of the toolbox, you're going to do your slump test beside the truck, and you're going to go, yep, this looks good, this doesn't. You might refuse some things, send it back, or adjust things. And so now you can make those gas pedal adjustments when you're actually making it, and then when we're actually the business professionals who are building, who are using it, we can also verify one back and forth from the other. And so a lot of times if things get stored, there's moisture content, there's all sorts of different measurements that are going into it, but once that spec gets hit, we can rock and roll and we can do things.
Yep, rinse and repeat, just like shampoo. We want to dial it in, we want to do the work here. Again, we've got the customer in mind. And so it all starts with the care of the bale, and then before that it starts with the farmer, right? So good farming practices, good farming technique comes into, like, why is that important to a processor? Well, we've showed you why that's important and how the multiple products come about from what we do here.
And so I want to forecast a little bit into the future a little bit, where if you've got somebody who engages with the farming community, and then you can go all the way to the level of good ag practices. Not quite, it's kind of like having an organic certification, but if you're an architect designing for a large government building, you're going to need to be able to verify all of those practices all the way back to the farm level. And then when you've got somebody like David who's coming in here engaging with the farmers, contracting those acres and verifying that what they're doing out in the field translates to what you're designing on the project, now you've got something to where you can connect those dots as a career professional, because it's important, because you're being called on to do that. And a lot of the architects are like, well, we want to do that as well. There's a strong desire, but you have to know all the industry steps that you take to meet those requirements. So anything else to wrap up as we conclude?
Ray, we want to thank you for giving us the ability to show you under the hood, take a look at in our kitchen, how we do it, why we do it. And down below, you're going to see our contact information. So you'll be able to reach out to us. Would love to help you on your next project, supply your next project, or just give you good advice on your project. So we thank you so much for sharing our house with you, and you're always welcome to come by anytime.
One of my concluding questions, what are some of the things that you're most excited to see made out of hemp coming out down the pipeline?
Ooh, I would like to see, I want to see the replacement of plastic. I think that's where we're going to grow into. There's 25,000 cool things out there. But I think if the scientists, and we're really getting into what this plant can do, maybe we can't replace plastic, but I've sure seen enough cooks and I've tasted some of their food, and it's pretty darn good right now.
Yeah, they're not 100% making the plastics out of hemp, but there's a large percentage of hemp in plastics currently. And then so when that's getting incorporated in the construction and build space, all those little things, whether it's the window and door latches or on up and on down, we're going to see that. And so we're glad to have you on, and we're glad to be here. And then if you're taking this for your continuing education, follow the instructions in the description, and we'll see you on your next successful hemp building project. All right, architects, you're called on for fire suppression and safety. We've simulated a nice South Texas day in the summer. Take it away, David.
Yep, fantastic. Through guidance of Ray and others that actually put this into practice, we're going to demonstrate a fire test on a block that we made utilizing a Texas-grown hemp plant.
Those in Arizona and New Mexico, you also get credit for it being hot, but we're in Texas, and so we sweat it out in the summer. And then this is the Hempcrete. Now it's encased in our little demo of wood, and we'll see how that does. But what we're going to do is we're going to put heat. We've got our heat measuring gun right here. So right now, we're at 63.3 degrees. And then we're going to take it a little bit hotter than that, and then we're going to measure the temperature on the other side as well. And then you'll get an idea of just the fire suppression power that you get with this as a building ingredient.
Fantastic, here we go.
Now we're already up to 600, 700 degrees, and we're going to keep going. Now you can see the wood that's the frame, it's starting to catch, but the hemp is not. So let's do another check right here. 800. 900 degrees. Now I'm going to go on the other side. $87 degrees, 86 degrees, 900 on the other side, 83 degrees on this side. That smoke you see is the wood. 1,030. So even with this being 1,000 degrees on the other side, my hand is safe right here, touching this in constant contact.
1081.
All right, so we've taken the heat off and we're still 600 degrees. This is cooling down, but you saw the tremendous pressure that this endured, and we're still at a point of where it would flame up if it were this hot. You can see the glowing right in here. I'm not going to touch that. I can feel the heat all the way over here. Now come back to the other side. This is a 3.5 inch piece. I can comfortably hold my hand on here, and this surface is 96 degrees at the point where 3 inches away it was over 1,000 degrees. It's still 600 degrees, but you saw how if these are two multifamily dwellings separated with a firewall of hempcrete, how much power that's going to have for the safety and the well-being of the occupants. We saw a little bit of smoke going on, but I want you to note that the wood, now we were pointing this right here, 1,000 degrees, it's still over 400 degrees right here. And so when it was 1,000 degrees right here, the wood was catching fire this far away, and then that's the smoke that you saw that was coming out. We've got another little sample block that doesn't have a wood frame around it, and we're going to show you how this does not smoke and flame out at all, but just wood will fail under such temperatures like this, where the hempcrete stays in place. And then if you have hempcrete encapsulating your wood, then this is going to keep that wood from igniting. This striking off. So before we're at 75 degrees on this side. Architects and building professionals, if we give you a sample of hempcrete and you want to get lunch, bet your colleagues lunch that they can set this block on fire. It's so bright I can't even tell where the laser's going. There it is, right in the middle. 1,090, 1,020. So we're hovering 1,100. 1,100 degrees. This is a 3-inch thick piece of hempcrete, and I have my hand in constant contact, and all it is it feels warm. So we're hovering at 1,100 degrees. Sustained 1,100 degree temperatures in the building material. It's basically glowing. Ready for the wood? How would wood do in comparison? set our stopwatches, 1001. Yeah.
Look at that. What was that, 45? A minute time frame, and now we've got wood on fire. We've been doing this for over 3 minutes now. No fire. I think I know what I want my house made out of.
Yeah. So the temperature on the wood, with it away from, with the flame away from it, it's still burning, it's smoldering. But the wood before, let's see down here, just catching the heat off of that powerful torch. The wood around it is at 160, 145. Let's go on the other side of this. We've been sustained at 1,000 degrees on the other side for several minutes, and it's not even over 100 degrees. I can still put my hand. This is the part of the demonstration where people usually get bored. But you can see the power and the fire retardancy. When I say fireproof, technically, eventually you will destroy the material. So I like to say damn near fireproof. Fire retardant is too hard to say every single time. So when we say fireproof, this is what we mean. We mean damn near fireproof. Very safe for the occupants on this side, and if ever there was anything like a raging fire on this side, woo! We're at 1,100 degrees plus, sustained continually. Probably, I don't know, sprinkle it on there. So what'll happen, it'll ash out, and then you can go back and replaster with more Hempcrete. All right, so before we start digging into this, my guess is it has only gone through maybe an inch, inch and a half maybe, within a 5-minute time frame. So to repair, you're just going to dig it out, and you could reapply and smooth over it with new material. That's getting hard. You can see the change in material. So, if you did have 1,000 degree fire and Hempcrete was the building material, you can remove the affected area and then come back in, mix your lime, hemp, water again.
Yep.
It'll plaster right over and repair.
Ray, that's probably a 1/4 inch or less.
Nice. That's amazing. So we had this burning for about 3 minutes on this one, 1,000 degrees, and it's still pretty hot, but we commented on the repairability of this. Hempcrete can come back in, the part that's not damaged, and you can replace it and plaster right over it. That's one benefit, but the other benefit, which is a tremendous one for the health and safety of the occupants in the circumstance of a fire, as well as the professional firefighters, is that there are no toxins emitted while that is under that type of heat stress.
See what that temperature is on that fresh material right here?
200, and then right over here, 100 degrees more about, 3.
Yeah. So, almost half inch.
Yeah. So it does ruin the material, but it stands the blast.
And then I was just going to say, another critical piece is that gives you time to get out.
Right. That's all fire suppression really does, is get the occupants time to get out in another area so that fire doesn't spread. Now, a lot of people put hempcrete around the outside envelope of the home because that's where the insulation performance is so enhanced. But many people are also choosing to have hempcrete on the partition walls, and then this is one of the reasons why. So multifamily duplexes or townhouses, that fire break between, now if you've got a fire, it's isolated to that unit. If you're using it as your partition walls, if there's a fire in the kitchen, the bedrooms are still safe. The fire alarms will go off. You can get out, have a safe route. So we hope this really encourages the architects and the design professionals to incorporate this in, because as we get density in the urban areas, we're going to need to be safe when we have that density, and this is how we do that.